Alright, so today I have done the some of the configuration on my microphone and see how far it goes with my audio. Let's continue solving the Leetcode problem. So the Leetcode problem is that we have to find the minimum operation to make the all element divisible by 3. So we are given an integer array nums. In one operation, we can add or subtract 1 from any elements of nums. So we have to return the minimum number of operation to make all elements of nums divisible by 3. So for example 1, we are provided by the integer arrays, which is from 1 to 4. Okay, maybe we go through the SQL draw and explain a little bit. So since we are provided by the 4 numbers of arrays in integers, what we can do is within the one operation, all the elements must be divisible by 3 using the 3 operation. So according to this, let's consider we have 1, 2, 3, 4. Why is this so small? Alright, a little bit technical issue on my side. So even though we are having the 4 integers, so for the 1, to make the 1 divisible by 3, what we can do is we subtract 1 from the 1, that will become the 0, so 0 is divisible by 3. That is our operation. We move to the next index, which is a 2, so which is a 2, and then we just add plus 1 to the 2, which will become 3, and then 3 is already divisible by 3. For the 3, we don't need to do anymore or anything, and then we move to the next index, which is a 4. So for the 4, we just subtract the 1. That's the reason why the operation is to the 3, and it is show up in the outputs of 3 in here. Since it is an easy question, I'm pretty sure the requirement and the constraint will be very low and very minimum. I think we can solve that pretty simple. Maybe my thinking was how about we just divide the numbers and alright, let's think as a barbarian and dummy way. Let's create a one variable called result, which is to keep track of everything, and then we need the count for the nums.count, and then what we need is we are going to iteration through the index. Let's call that index in 0 through the count. What I'm going to do in here is maybe I will just create a temporary array to keep track of everything. And then what I can do in here is I'm going to check like nums of index is not divisible by 3. Yeah. And then I can simply add to the append to the numbers of index. And then what I can do in here is I can go through my temporary array. Let's call like nums in time. So what I'm going to check is there's a hint given by the Leetcode. So for the hint 1 is x is not divisible by 0. We can always increment or decrement x such that we only need one operation. So next is I'm gonna copy this hint and let me use in here. Let's call that result plus equal to the minimum of num. That could be the not the minimum of none, should be the num in here, and then that will be the num in here, and I just return the result in here. Let's try to run it, but I did my wait, what do I do wrong? Okay, I just missing the one bracket at the end. Alright, if I am trying to submit this problem, the time complexity will be the O of n. I think the space complexity is also O of n, but I think we can do better in our case. Okay, let's clean up this. And how about just use only one result variable? And then let's go like for num in nums. We can simply check like if none is not more than bind 3. I'm gonna just +1 to the result and then just return the result in here. How about trying to submit this? That would be the O of n for the time complexity, and space complexity will be O of 1. Yeah, since I'm not the premium user, I am not able to see it. Makes sense. But if we want to impress the interviewer during the interview, we can do the one-liner. Let's do it like this. We don't need the result. Let's use like return nums of filter by simply using the $0, which is a arbitrary parameter in the filter, which mod bind 3 not equal to 0, and I'll just return the count. Not sure that is a solution or not. I think it's pretty straightforward than the previous answer. Yeah. Oh, I beat the 100% in Swift. So that's literally the O of n for the time complexity and O of 1 for the space complexity. Yeah, that's pretty much for it, and see you in the next video. Bye.